Welcome back to our Ansible series. Today, we are diving into two powerful features that will make your playbook more flexible and efficient: variables and handlers. By the end of this video, you will understand how to use variable to make your code reusable and and how handlers can automatically restart services only when needed. So let's jump on our server quickly. When I list my repository, my local repository, Yon Ansible tutorial, I'm going to move on my inventory file quickly so you will be able to see how I've organized my different server. So as you can see right there, I have container server group and Linux server group. In container server group, I have two Ubuntu one, Ansible also equal to this, which corresponding with the first container Ubuntu that we have, and we have Ubuntu 2, which is defined by Ansible OS 172 and 2 by the end. So I already talked about my two container server during during the previous video, so I'm not going to stay a lot on that one. And my Alma Linux server, which is my third target server right there. So I just want to share that one with you before to continue with all the explanation. Okay, so what are variables? Let's start with variable right now. Think of variables as containers that store values you want to reuse throughout your playbook. Point to var section. You can see the group var directory that I have defined, right? So everything that you're going to define going to point to this group var directory, and everything that you have set up over there. Let me cd that group var. You can name it also host var, so it depends on you. Okay, so you can see that inside the group vars I have the container servers.yaml and Linux server.yaml file. If I cut each of these, you can see that inside Linux server.yaml, I have command message defined by I from Alma Linux on Linux. And if I cut the next one, container, you can see that I have common message defined by hello from a Docker Ubuntu server. Okay, so you should be able to see that each of my YAML variable file is pointing on a specific group. You have container server right there, and you also have a Linux server over there. Okay, so these are the basic configuration that you have to set up before to start everything. Okay, and you can see on my program here that I've defined it. I've defined a couple variable. Here we have defined two variable: service name set to nginx and config file set to temp test.conf. Okay, so that's a little bit it about variable. The beauty of variables is that if you want to deploy Apache instead of Nginx tomorrow, you just change one line instead of running through your entire playbook. So notice how we use variable with the curly braces, double curly braces, and we define the name inside the double curly braces syntax. See here where we reference service name and config file on my playbook right there. This make our playbook flexible and maintainable. Okay, so what about handlers? What are handlers? Handlers are special tasks that only run when they are notified by other tasks, and they only run once at the end, even if multiple tasks notify them. Look at this notify statement in our task. When a task makes a change, like installing Nginx or updating a config file, it notifies the handler to restore the service. So the key benefit that you can keep in your mind right now about handlers is first, efficiency. Service only restart once, even if multiple tasks trigger it. Second, we have the conditional, only once if something actually changed. And third, we have clean, separate, which means separate the what from the when. Okay, so what problem we are solving using this endless stuff and so on. Is where it gets tricky in the real world. Different Linux systems use different service manager. Some use systemd, others don't. Some call the service Nginx, others call it HTTPD. Oh, you can see on the screen quickly a couple error that I've encountered when I was trying to set up this awesome playbook with variable and handlers. This is why our playbook includes detection logic to handle these differences automatically. Okay, so smart services detection. First, we detect if systemd is available by checking for this directory. You can see on my screen with the task name check if systemd is available and running. Start path, we provide a path of system, and the register keyword saves the result in a variable we can use later. Okay, then we detect the actual service name because Nginx might be called HTTPD on Red Hat system, and it's the case with the Alma Linux, which is the third target that we are using on our Ansible series. So let's see the task check what Nginx service name is actually available. So you can see the shell command that are provided on the screen. This shell command looks for the actual service name and store it in actual service name variable. Okay, so what about smart handlers in action? Now is the clever part. We have two handlers with the same name but different condition. Handler 1 is the text to restore service using systemd, and the name we are using variable actual service name act the actual service name that standard out on default service name. So state is restarted when systemd available that start that exist, Ansible service manager equivalent to systemd. So you can understand that this first one gonna be executed when Ansible service manager is equivalent to systemd. Okay, and the second one is the one that you're gonna use when Ansible service manager is different, it's not systemd. Okay, not systemd available start exist, and Ansible service manager is not equal it's not equivalent to systemd. Okay, so that's a little bit it about this part. When we start service, it's triggered on system uses the systemd module. Unknown systemd system, and is the case for container server that we are using, uses the generic service module. Both use the detected service name with actual service name standard out pipe default service name. Okay, so what about the flow in action? Let's trace through what happened. Variables defined at the top, flexible and reusable, right? Detection tasks run, figure out the system capabilities. Then main task execute, install package, create config. Then task notify handler, hey, something changed, restart the service. Then handler runs hunt at the end using the right method for each system. Okay, so let's see the debugging output on the screen right now. So I'm gonna run. I'm gonna cut my deploy. Let me cut quickly this file. This playbook file that I've run until the end. So when I cut it, you can see maybe I'm gonna use the vim comment in order to show you more clearly what we have here. So you can see that on the first line, we have our first task name, deploy and manage services using variable and handlers. The hosts all become true, okay? And we have defined our variables, vars, service name is Nginx for this case, and config file, temps. So we have a couple variable exactly as I've explained during the beginning of this video. Then we have our specific task. So you have to provide all your variable before your task. Okay. So inside our task, you have the first task that's going to be about display the service manager for debugging. So debug and message is service manager, and depending of the group that we are working on or we are working through, we're going to have a specific message that is going to show up, and you will be able to appreciate it in a couple of seconds. So we have the next task, check if systemd is available and running, and I've explained it during the introduction of this video. You can see the path and the register. After that, we have the task display system, the availability, and we also have the debug message that's going to display on our screen in a couple of seconds. Then we have the create a config file, and over there we are using our variable on the destination. You can see that we have config file that we have defined on the header of our playbook, and we also have a notify, our first notify here that's going to make restart services. Okay, so that's more about the notify that handler is working with. And when I'm moving down, we have the task name ensure service name is installed. So you're going to see how the output going to look on our screen in a couple of seconds. Okay, so let's get down. Okay, and we also have a notify here that's going to restart the service. Okay, so if it's installed, if the service is installed, the handle by the end should restart the service. Okay, so this is the notify option that I was talking about. And after that, we have a name. Check what Nginx service name is actually available. And we have the shell command that I was talking about. So you can just drop a post. And I also going to provide this the link for this code in the description, so you will be able to access it on the on my GitHub account, on my repository, and uh, watch more. And let me know in the comments if you have a question. Okay, that's a little bit it. I've tried to explain it. So we have a if statement with a couple else if to check what Nginx service name is actually available, and register actual service name. Okay, and this one change when it's false. And I also add the module in your error to yes. Okay, after that you can see that we have name, display actual service name font, and we use the debug module. We we are we are we are displaying the message. Okay, actual service name detected, and you can see we are using the variable. Okay, you're going to see how it's going to look on our screen in a couple of seconds. Okay, after that we have the section on handlers. Okay, so about handlers, as I said before, we have uh, two main handlers. The first is named restart service, and systemd. Using systemd and the name, we have our variable actual service name that uh, standard output, and pipe default service name. Okay, and the state restart, daemon reload, yes, when systemd available that start that exists, and Ansible Service Manager is equivalent to systemd. So I already explained this in the introduction. So this one going to execute it for Alma Linux, which is a Red Hat full server application. And this one is about my container where you don't have systemd. You don't have systemd on Docker container server. So we're going to use the second handler, which is named restart service, and service name, actual service name. And you can see I already explained it when we not when not systemd is available. Okay, so let me close this quickly and let's execute our playbook. So I'm just gonna Ansible playbook deploy that YAML. I can ask the that check option and run it in uh, in the test mode in order to see if you have some issue. But since I already double check on my code, I'm pretty sure that everything gonna be alright. But I just want to let you know that you can use the data check option when you are working on yours, and make sure that everything works before to deploy in production. Okay, so I'm gonna run it directly. But right now I forgot something. Since I've started with my SSH agent, I should use it. I should always use it to avoid issue on my play. Okay. I've talked on the episode 2 on this here how to set up your SSH agent. So if you would like to know more about it, let's check the first episode of this Ansible series on this channel, and you will be able to learn how to do that, and you will love it. I'm pretty sure. So let's see. Display the service manager for debugging. You see service manager, systemd, Ubuntu, service manager. So you can see right there, check if systemd is available running. Okay. display systemd availability. Okay, right there you can see that the availability is false for our both Ubuntu server and true for Alma Linux. Create config file, everything work. Ensure Nginx is installed, everything got installed. And task display actual service name font. Okay, so okay, and task display actual service name font. Actual service name detected, Nginx. Yep. Then running enter. Okay, so you can see what we got here. So the ender has kept on Ubuntu 1 and Ubuntu 2, and we got a fatal error. Limit Alma failed. Change false. Message could not find the requested service HTTP host. Yeah, but overall we have pretty much everything work 100%. Okay, so you were able to see that everything got triggered normally. But I'm wondering why we got this error here. Failed change false. That's sweet. You were able to see everything works normally. Okay, so I'm going to come back on the top right there and explain line after line. So you can see that on this next play, the gathering fact 100%, display the service manager for debugging. So you can see that we have everything works. Check if system is available and running. Everything is okay. Then display systemd availability. You can see that for our buffer Ubuntu we have false and true for Alma Linux, which is a Red Hat server, Linux server. So that's normal. Create a config file. So we use our variable here to create our config file, and when we are moving down we have ensure Nginx is installed, everything is okay. Check what Nginx service name is actually available, and you see we are okay everywhere. Display actual service name font. So we have Nginx for Ubuntu, and for Alma Linux we have HTTPD. So yeah, the play recap, everything works 100%. Out 8, and out 8. Okay, so it's just awesome. So let's trust through what happened. Before to close this video, talk about a couple best practices recap. What about variables? We have to use them for anything that might change. There are clear descriptive names, group related variable together. Okay, so when you use them for anything that might change, we use variable for clear descriptive name and also for group related variable together. And what about handler? Handlers only for tasks that should run conditionally. Use descriptive names. Include error handling with in-your errors. Test different system. Not everything use systemd in our case, for example. This playbook now work across different Linux distributions and init system that's the power of combining variable with smart handler. Thank you for watching until the end. Please hit subscribe and the notification bell so you don't miss the awesome last episode of this series that is coming pretty soon. And if you didn't watch the previous one of this series, let's watch them, and I'm 100% sure that you're really going to appreciate, you're really going to love them. Thank you for watching once again, and bye.